Hi science students, welcome back to another day of digital learning. Today's focus is going to be on differentiating between acids and bases. So you're going to need a piece of paper in order to take the notes. If you need to pause the video to go get a piece of paper and a pen, please do so. Go ahead and write acids and bases as a title across the top. We're going to start with the acids and then we'll work our way over to the bases. We're going to compare these two to one another because they are quite different. So let's go ahead and start with the definition of acids. So acids are going to be substances that dissolve in H2O to release hydrogen ions. So acids are going to be put into water, and when they react with that water, they're going to release hydrogen. All right, some examples of acids that you may know are going to be battery acid, lemons, and this one's a little hard to see, but this is a milk carton. So batteries, lemons, milk, all of those are examples of acids. If I were to mix them into water and dissolve them, they are going to release hydrogen or H plus ions. Some properties of acids are going to be that they react with metals to form that hydrogen gas, that green H plus that you see there. They're going to taste sour. They're going to feel sticky to the touch. And they're usually going to be liquids and gases. This material, as far as examples and characteristics of acids, should sound a little familiar to you. You've heard it before, but the part that we're going to focus on as physical scientists are going to be how it impacts how dissolving acids impacts a solution's pH level. So we use a pH scale, and we'll talk more about that in the coming days, but we use a pH scale in order to determine if something is acidic or basic, but also to determine how acidic or how basic it is. So if I'm dissolving an acid into water and it's releasing that hydrogen has an impact on the pH level of that solution. So if I look down at the bottom here, I want you to write an increase in hydrogen concentration, which means as I dissolve my acid into that water and the hydrogen is released, I know that my concentration of hydrogen in the water is going to be higher. I'm increasing the concentration. When I do that, though, I am decreasing the pH of the solution. So the more hydrogen present, the more that the pH of the solution will decrease. Bases are going to be pretty much the opposite. They're going to release a different form of ion, and it's going to impact our solutions and our pH levels in those solutions differently than acids would. So let's talk about bases. So bases are going to be substances that dissolve in water to release hydroxide or OH ions into the solution. Some examples of bases are going to be bleach, soap, and baking soda. There are other examples of acids and bases outside of these 6, but they wouldn't fit on my paper. So we will continue to delve into different acids and bases beyond these. Some properties of bases are going to be that they react with metals to form hydroxide ions. They're going to taste bitter. They may feel slippery to the touch. And they're going to form water. This goes really for acids and bases. They're going to form water when mixed with acids, or they're going to form water when mixed with bases. So if I were to have something that's incredibly acidic and I pour a base into it, it's going to neutralize if they are the same pH as one another. It's going to neutralize and cancel each other out. That neutralization essentially is forming water. So let's talk about how bases being dissolved into water are going to impact the concentration within the solution, but also the pH in the solution. So the first part of bases, since they are dissolving and releasing hydroxide, is that hydroxide is going to cause a decrease in hydrogen concentration. So as I dissolve the base, the hydroxide is released. My hydrogen concentration in that solution is going to decrease. That decrease in the hydrogen concentration is going to have an impact on the pH level of the solution as a whole. So as I decrease the hydrogen concentration in my solution, I'm actually increasing the pH of the solution. So as I decrease the hydrogen in my solution, the pH increases. So bases are going to have high numbers as their pH, and acids are going to have low numbers as their pH. Things less than 7 are going to be considered acidic. Things greater than 7 are going to be considered basic. So as we see in this pH scale here, our neutral is number 7. We see pure water. Anything to the left or anything less than 7 is going to be considered acidic. The lower the number, the more acidic it is. So we see gastric acid is the most acidic on this pH scale that we're looking at. The closer to 7, the closer to neutral that the solution is, the less acidic it's going to be considered. So milk is much less acidic than lemon juice, but still acidic. Anything that is to the right or higher than the number 7 is going to be considered basic or a base. So we can see that concentrated solutions of alkali metals and bleach are going to be much higher bases than, say, eggs, but both of them are still going to be considered basic. And if we were to take a base and mix it with an acid, we know that it's going to neutralize and it's going to release some water. That's everything I have for you today. So have a really good day, stay safe, and I'll see you tomorrow. Bye-bye.